Machine interpreting is an emerging area of artificial intelligence that aims at building machines able to translate spoken text from one language to another in real time. This can either be done in the modalities consecutive or simultaneous. Machine interpreting and offline spoken language translation share many traits, the latter being used to translate pre-recorded videos. Generally speaking, machine interpreting aims at reducing language barriers by means of unsupervised oral language translation. It can be used in informal settings like booking a table at a restaurant, following the live stream of a YouTuber, as well as in formal ones like translating a lecture or political speech in real time. The performance of machine interpreting has been majorly improved within the past few years. Starting from the rather artificial problem of translating oral utterances recorded under controlled conditions with restricted vocabularies, strong domain limitations, and the necessity of a constrained speaking style. Nowadays, research as well as experimental and commercial applications are driven towards the task of translating real-life spoken language without any particular constraints. This huge progress is mainly caused by the use of modern machine learning algorithms, especially neural networks, and the availability of big language data. There are at least two approaches to machine interpreting: the cascading and the end-to-end approach. In the cascading approach, the process of oral translation is broken down into sub-processes that can be modeled in computer programs. The simplest approach consists of using three separate components. Automatic speech recognition translates the spoken words into written text. Machine translation translates the written text from one language to another. And text-to-speech synthesis produces a spoken version of the translation. This approach is used, for example, in the Google Translate app. The advantages of this approach are that it builds on available technologies, is transparent as far as the sequencing of the task is concerned, and is extensible, thus new components can be added to the sequence. These systems too do have their flaws, such as error propagation, the use of large translation models trained with written data, meaning they are not able to solve phenomena occurring in oral language, such as hesitations. As a consequence, a noisy transcription provided by the ASR, for example because of typical ASR errors, such as disambiguation of homophones, may impair the successive machine translation process and so forth. The end-to-end approach applies similar machine learning techniques used for machine translation or ASR directly to bilingual speech data. This is so that they create models able to directly translate speech from one language into speech in another, without relying on a transcription of the text. Since the tasks are not divided into steps, they are able to avoid compounding errors between recognition and translation, better handling of proper names and faster translation. As the technique is still in its early stages, the output quality isn't as good as the cascade system ones. Having those two systems, they can be merged together to hybrid systems. This means, for example, the combination of speech-to-text translation with a speech synthesis module. Despite improvements, machine interpreting still has to cope with many challenges of real-life multilingual communication in order to reach a good enough quality to make its use suitable for certain contexts. It still operates exclusively at a pure linguistic level, meaning that it only processes the surface of communication, which is its language, and is unable to make sense of typical aspects of verbal communication, such as prosody. NLP can be used to improve these interpreting system components, as the required understanding is not within reach, by for example adding new layers of elaboration like speaker diarization or emotion recognition from linguistic and paralinguistic properties of speech. But solutions that may lead to a true understanding of language, situation and communication goals are still far to come. However, using existing and emerging tools could lead to the use of machine interpreting in real-life scenarios. Depending on the context and the user's expectations, these systems may be good enough for some form of multilingual communication. Thus, a mixed scenario where both machines and humans will deliver interpretation services may become reality.